Today we're going to solve a problem with a large number modulus a prime. We're going to use Fermat's little theorem, and we're also going to use binary exponentiation. So the first thing to note about this problem, 2 to the power of 2 to the power of 60 mod 107 equal a, where a is the remainder, is that the number 107 is prime. This is very useful because we can apply something handy to Fermat's little theorem. And with that, we can find the period is 106. Any number that's prime minus 1 gives its period, in this case 106, because the number is 107. The first step here is to simplify. We're going to simplify the equation into the form 2 to the k mod 107, where k is equal to 2 to the power of 60. We're going to use this because it's just a little bit easier to understand this way, and it looks better. Secondly, we're going to find 2 to the power of 60 mod 106 equals r, which is the remainder of that. We can apply Fermat's little theorem. We want to find 2 to the power of 2 to the power of 60 congruent to 2 to the 106 times n plus r, where 106 times n plus r is actually equal to 2 to the power of 60. With Fermat's little theorem, it means that the first term, 1 to the power of 106 times n, is always going to give a remainder of 1, and 2 to the power of r mod 107 is going to give us our answer, which is a, and which is nice. So in order to solve it, let's do step 2 first, 2 to the power of 60 mod 106. We're going to use some binary exponentiation. Oh yes, and it's equal to r. Binary exponentiation, where 2 to the power of 60 is actually just equal to the multiplication of 2 to the 32 by 2 to the 16 by 2 to the 8 by 2 to the 4. For each term, we're going to find its remainder modulo 106, which I've done here for your convenience. You can do this on your own time if you'd like. The trick here is to notice that the remainders multiplied together, mod 106, is actually congruent to the large number, 2 to the power of 60, which we've expanded here, mod 106. These are equivalent. They give you 64 as the remainder, which gives us our r term. So the next step is to go back to step 1, actually, and find a equal to the 64 mod 107. Why is this equation correct? Well, a is equal to 2 to the power of 106 times n plus 64 mod 107, which we can then break down into two terms, 2 to the 106 times n, 2 to the power of 64 mod 107, where 2 to the 106 times n mod 107 is always congruent to 1, and 2 to the 64 mod 107 is always congruent to a. We're going to use binary exponentiation again, because 2 to the power of 64 might be too big for your calculator. So we can actually break down 2 to the power of 64 mod 107 into 2 to the 32 multiplied by 2 to the 32 mod 107, and the remainder of 2 to the 32 mod 107 is 29, where 29 times 29 mod 107 is equal to 92. And all of these equations are congruent to each other. They'll always give you 92. The answer, A, is therefore 92. Nice. Now, if you guys found this helpful, you might also want to consider finding 2 to the power of 2 to the power of 50 mod 107 in your own spare time. That'll give you an answer of 41. And if you have any questions, please do leave a comment in the comments below. If you found that this video was helpful to you in any way, please leave a little like, and I'll continue making some more of these. Thanks!